Now, preparation of hydrochloric acid. Till now, we have observed all the properties that how hydrogen chloride gas prepared in the laboratory. Then we have seen the fountain experiment, and now we are going to see how hydrogen chloride gas is converted into hydrochloric acid. Now, the simple method which says that use a beaker, take a delivery tube, pass hydrogen chloride gas into water, and there is a hydrochloric acid formation will start and will take place. But we do not select this method. The reason behind it, the solubility of gas in water is so high that because of that, the water level will rise up inside the delivery tube. The pressure, the solubility of gases is so high in the water that inside this, the pressure will be decreased and outside pressure will be more. It will force this water to rise up inside the delivery tube. Now there is no passage for a gas to go in and the formation of hydrochloric acid will stop. So we don't use delivery tube. Instead of that, we use a very simple experiment that is called inverted funnel experiment for the preparation of hydrochloric acid from hydrogen chloride gas. The rim of the funnel should be in contact with the surface of water. From here we pass hydrogen chloride gas, it goes inside the water and the hydrochloric acid starts forming. But now again over here, due to the pressure which is less over here, it may happen that water will rise up. That going water inside this is called back suction. To prevent or to minimize this back suction, we have taken this inverted funnel arrangement. The advantage of this using funnel arrangement, it gives larger surface area compared to this delivery tube, and it minimizes or it prevents the back suction of water which was taking place over here. The diagram in the ICSE board, they've asked very less number of diagrams, but it is one of the diagram which has been asked in the board question. How do you convert hydrogen chloride gas into hydrochloric acid by using funnel experiment? You have to show hydrogen chloride gas is a beaker containing water. This is an inverted funnel, and funnel experiment it is called. From here, 1 mark question, one more. Hydrogen chloride gas is converted into hydrochloric acid by using delivery tube. You will say no, we will use inverted funnel experiment. We cannot directly convert into water, dissolve into water. We have to use funnel experiment. Back suction of water, you can prevent it by using funnel. It reduces back suction or prevents or minimizes back suction, and it gives larger surface area for the absorption of HCl gas. Now we are going to study chemical properties. Now Mg plus hydrochloric acid. This is the basic reaction which you might have done in your chapter hydrogen last year in the 9th standard. Mg plus hydrogen chloride, when it combines it forms MgCl2 plus H2. In many schools, they ask a very basic question: what will you observe when magnesium is treated with hydrochloric acid? You will get hydrogen gas, which is a colorless, odorless gas. It is a neutral gas which burns with a pale blue flame and a pop sound. You can see Mg, Fe, same reaction, Fe, Mg, FeCl2 plus H2. Sometimes examiner asks you convert Fe to FeCl2. You have to keep in mind that I have to use dilute hydrochloric acid plus FeCl2 plus H2. You can see same way if you have been asked Zn plus HCl. The same reaction will get ZnCl2 plus H2. The question to you, can copper react with HCl? Obviously no. Why? Because the position of copper is below hydrogen in metal activity series. So copper cannot displace hydrogen from HCl, and you can't get CuCl2 plus H2. Then how will you prepare CuCl2 by using HCl? Compulsory you have to take either copper oxide or copper carbonate. Copper oxide is black in color and you get copper chloride, which is blue, which is soluble in water. So you can write for your observation that blue solution is formed. Ammonium hydroxide plus HCl, you get NH4Cl plus water. So this is a reaction between acid and base. All metallic oxides are basic in nature. Ammonium hydroxide is again an alkali. So acid and base react, they form salt plus water. Salt plus water, and this type of reactions are called neutralization reaction. What do you mean by neutralization? Where acid and base react, they form salt and water. These are the two more main products. So after this, next is you take carbonates plus acid. They are the fixed product. So children, you don't have to mug up any reaction. Chemistry, you have to understand it's a general reaction that carbonate plus acid always gives salt, water and carbon dioxide. Now, you can take sodium carbonate, calcium bicarbonate, and at the same time you will get salt, water and carbon dioxide. Instead of sodium carbonate, you can take potassium carbonate, K2CO3 plus HCl. Will give you potassium chloride plus water plus CO2. So by changing any metal, sodium, potassium, you can take zinc carbonate, copper carbonate, you will get corresponding salt, water and carbon dioxide. In all this reaction, the observation for CO2 is fixed, it is colorless, odorless, acidic gas, which turns lime water milky and no effect on acidified KMnO4 solution. Because observation in the section 1 for 5 marks, and children always find it little difficult because they don't know what to write for the observation. So they have to understand that with salt you are getting water and carbon dioxide. Since sodium chloride is a soluble salt, so you can't write any observation. But yes, for CO2 you have observation. They can ask you identify the gas evolved when any acid is treated with any metallic carbonate or bicarbonate. Name the gas evolved. Carbon dioxide. Observation, again it is a colorless, odorless, acidic gas, turns lime water milky and no effect on acidified KMnO4 solution or K2Cr2O7 solution. Same way calcium bicarbonate. Sometimes students forget to add CaHCO3 twice because the valency of calcium is 2. So CaHCO3 twice when combined with hydrochloric acid, it gives salt, water and carbon dioxide. So you can use sodium bicarbonate, potassium bicarbonate with acid, salt, water, carbon dioxide. Next, if you will see, I have given a summary of some reactions. Same metal reacts with acid, salt and hydrogen. Metallic oxides and hydroxide treated with HCl, acid gives salt and water. Sodium carbonate, as we have discussed, reacts with HCl, gives salt, water and CO2. In all these gases, hydrogen gas is evolved, which we say hydrogen gas, colorless, odorless, neutral gas, burns with a pop sound with a pale blue flame. CO2 you can see it is a colorless, odorless, acidic gas, turns lime water milky, no effect on acidified KMnO4 solution. Next, sodium carbonate, calcium bicarbonate, salt, water, CO2. Here also salt, water and CO2. You can write over here. Okay. Now, this is in all cases I am using dilute hydrochloric acid. Sodium sulfide. Sodium sulfide when distributed with hydrochloric acid gives salt, water and SO2. Examiner's favorite question again from here, that how will you distinguish between Na2CO3 and Na2SO3? How will you answer this? Add dilute HCl to both salt solution. On adding acid to both salt, this will give out CO2 gas and Na2SO3 gives out SO2 gas. So here CO2, here SO2, so you will mention here a colorless, odorless gas which turns lime water milky and no effect on acidified K-4 solution. Here you will write colorless, suffocating odor gas, which turns lime water milky and change the color of the acidified K-4 solution from pink to clear colorless. Instead of sodium sulfide, you can use sodium bisulfide. NaHSO3, yes, sodium hydrogen sulfide, same product NaCl, H2O and SO2. So in the chapter we have started with the first distinguish, give a chemical test. Yeah, what will you observe when you add HCl to sodium carbonate or sodium sulfide? It's very important. Please note down sodium carbonate, sodium sulfide. You have to add acid to both the salt solution. Please don't forget to write solution. Here you will not mention the name of the gas, but you will mention a colorless, odorless gas. Turns lime water milky, no effect on acidified K-4 solution. Here you will write colorless, suffocating odor gas. Turns lime water milky and changes the color of K-4 from pink to clear colorless. Next is iron sulfide. Iron sulfide, or you can take sodium sulfide, treat with hydrochloric acid. This is Fe and Cl gives you a salt FeCl2, and H and S will give you H2S gas. It is a colorless, rotten egg smelling gas. Hydrogen sulfide. It's a colorless, rotten egg smelling gas, turns moist lead acetate paper silvery black. See children, whenever you have to write, when any gas is evolved, compulsory we have to write a confirmatory test for that particular gas. Here, if you are writing colorless, correct, it is having rotten egg smell, but smell is not a confirmatory test. So you have to mention a colorless, rotten egg smelling gas, turns moist lead acetate paper silvery black. That is a confirmatory test for H2S. Silver nitrate, when treated with hydrochloric acid, Ag and Cl will form AgCl, H and NO3 forms HNO3. AgCl is a white precipitate. Again, silver chloride. What do you mean by precipitate? Precipitate means insoluble salt. When silver nitrate is mixed with hydrochloric acid, you are getting white precipitate of AgCl, and this AgCl is soluble only in excess of ammonia solution. Ammonia solution can also be called as NH4OH. So again, favorite question of the examiner, name a chloride which is insoluble in cold water but soluble in excess of ammonia solution. Your answer will be silver chloride. Or you can be asked, name a chloride which is soluble in excess of ammonium hydroxide. Yeah, silver chloride is soluble only in dash, we will write ammonium hydroxide. Similarly, lead nitrate treated with hydrochloric acid gives you lead chloride and HNO3. Now PbCl2. PbCl2 is again a white precipitate. These are the two chlorides which are insoluble in cold water. This is soluble in excess of NH4OH solution, whereas lead chloride is soluble in hot water. So they can ask you, name a chloride which is soluble in hot water. That is lead chloride, which is a white precipitate soluble in hot water. From here, the second test, how will you distinguish between hydrochloric and nitric acid, which we will be seeing later on. So silver nitrate, lead nitrate treated with hydrochloric acid gives white precipitate or curdy white precipitate. AgCl is soluble only in excess NH4OH solution, whereas lead chloride is soluble in hot water. See, at the same time, HNO3 is formed. Now, moving further, the reactions. Because once you learn the reaction for HCl, it is very easy for you to remember the reaction for HNO3 and H2SO4. Sodium thiosulfate. Sodium thiosulfate, when treated with hydrochloric acid, it gives salt, water, SO2, and here you get sulfur, which is yellow particles. The reaction is more or less similar like sodium sulfide. Thio means sulfur. Sodium thiosulfate, when treated with hydrochloric acid, salt, water, SO2 and S, which S is a yellow particles of sulfur which you will find at the bottom. Now, MnO2, this manganese dioxide, lead dioxide. This is red lead. Now, these all are oxidizing agent treated with HCl. When they are treated with HCl, since they are oxidizing agent, they convert HCl into a greenish yellow gas, chlorine. So MnO2 plus HCl gives salt, water and chlorine. So hydrogen chloride gas is oxidized into chlorine gas, which is greenish yellow. So they can ask you to give a chemical test to distinguish between CuO and MnO2. Copper oxide, black. MnO2, manganese dioxide, is also black. So you will say add concentrated HCl to both salt solution. So when you are adding concentrated HCl to both salt solution, here no gas is evolved, because as we have done that CuO plus HCl gives salt and water, but MnO2 gives out a gas, greenish yellow gas is evolved. Greenish yellow gas is evolved, which turns moist starch iodide paper blue black. So again, CuO, we have seen the first chemical test, Na2CO3, Na2SO3. The second is CuO and MnO2. Both are black. Add concentrated HCl to both. Here no gas, here greenish yellow gas is evolved. And whenever, again as I say, whenever any gas is evolved, you have to write a gas along with its state. So you will say greenish yellow gas is evolved, which turns moist starch iodide paper blue black. So you can see the oxidizing effect of manganese dioxide. On the same line, PbO2, PbCl2, water and Cl2. Reaction without balancing and without condition is of no use, so you have to mention the conditions. Now we are moving towards the last part of the chapter, that the uses of hydrogen chloride and how aqua regia can be made by using hydrochloric. Aqua regia is a mixture of concentrated nitric acid and concentrated hydrochloric acid in the ratio 1:3, which is called aqua regia. In that, nitric acid is an oxidizing agent which oxidizes HCl into nascent chlorine. Nascent chlorine means highly unstable, highly reactive. It forms NOCl, water and nascent chlorine. Aqua regia is used to dissolve noble metals like gold and platinum. So first question, aqua regia. The aqua regia is a mixture of concentrated nitric acid, concentrated hydrochloric acid in the ratio 1:3. Name the nitrogenous compound formed, nitrosyl chloride. Even they ask sometimes correct the statement. Nitric acid and hydrochloric acid in the ratio 1:3 forms aqua regia. So you have to mention concentrated nitric acid and concentrated hydrochloric acid. So even that small part, even though it's concentrated, you have to write, because by default if you are not writing concentrated, it means it is dilute. So please concentrated HNO3, concentrated hydrochloric acid gives NOCl, water, 2 nascent chlorine, which combines with gold and gives AuCl3. With platinum, it forms PtCl4. If examiner asks you, give a reaction of gold with aqua regia, you can't give this direct reaction, because this chlorine will be prepared at the site of reaction. So by default, you have to mention that this reaction HNO3 plus HCl gives NOCl, water and chloride, nascent chlorine, which combines with gold and platinum gives AuCl3 and PtCl4, which dissolves noble metals like gold and platinum. Now, how will you check that the given acid is hydrochloric acid only? Add AgNO3, which treated with HCl gives white precipitate, which is soluble in NH4OH only. It is insoluble in dilute HNO3 and cold water. Once you get white PPT, only hydrochloric acid is only, because this is distinguished between HCl and HNO3. Again, the favorite question of the examiner, and we will get white PPT of AgCl. This AgCl, which is formed, you can see it is soluble in excess of ammonia solution, ammonium hydroxide, and you are getting diamine silver chloride and water. So this test is used to distinguish between HCl from HNO3. So children, we have seen the uses of HCl also, it is used in Aqua regia, it is used for polishing metals also, to dissolve for the pickling of metals, and HCl is again widely used in other chemicals preparing also. So children, we have summarized HCl, the laboratory preparation. After laboratory preparation, we have seen the fountain experiment, funnel arrangement, and the different reactions of HCl with the metals, with carbonates, with sulfide, with nitrates. So HCl, we have finished the topic. Thanks a lot. Thank you very much children. We will be starting tomorrow with the new topic, nitric acid. Thanks a lot.